Okay guys, welcome to this video looking at the AS Pure Maths exam style questions for the Core 1 Edexcel, okay, for the old specification, and it's looking at algebra and functions, and it's looking at the exam style questions from the old Edexcel specification for the AS Pure Maths, okay, so this is relevant for year 12 candidates and even year 13 candidates as well. Okay, and some of it may be revision and a refresher for GCSE further maths and GCSE higher tier maths. Okay, as ever guys, feel free to pause the video, okay, as I do these questions. Okay, have a go at the questions first, okay, and then come back, press play, and let me know how you got on in the comment section by attempting these by yourselves, okay. But if you're not comfortable doing that, then that's fine. Please bring a notepad and a pen or a pencil and take some notes, okay, for today's video. This is question number 1. Write root 75 minus root 27 in the form k root x, where k and x are integers. So it's simplifying surds, okay. So I can write root 75, guys. So I can write that as root 25 times root 3. What I'm trying to do here, guys, is I'm looking for the highest square number factor that goes into 75. So this question requires your knowledge on square numbers, okay? So the square root of 25, we should know that's equal to 5. So I have 5 lots of root 3. Okay, so root 75 is equal to root 25 times the square root of 3. Okay, and this is now in its simplest form. Okay, so make sure that you're happy with your square numbers. If you're unsure, your square numbers are 1, 4, 9, 16, 25, 36, 49, okay, 64, 81 and 100. Okay, that is the first 10 square numbers. Okay, so remember that a square number means a number that you times by itself and it gives you this square number. So I can work backwards by taking the square root of any of these numbers and getting a whole number answer, hence the word square number. Root 27, guys, we should know that's equal to root 9 times the square root of 3. So the square root of 9 times the square root of 3, guys. Okay, root 9 simplifies to 3, so it's 3 lots of root 3. 3 times root 3 is equal to 3 root 3, guys. Okay, now I have it in the form 5 root 3, take away 3 root 3. Now I can take them away, okay, because I've got like a common third here. Okay, so I'm going to get 2 root 3. Okay, so the value for k will be equal to 2 and x will be equal to 3. I'll put a 5 there. Okay, if you're interested, so k would equal to 2. Okay, and x would equal to 5. Okay, this is all to do with simplifying. X would equal 3, sorry, not 5. Okay, this is all to do with simplifying surds, okay, finding like a common base surd, okay, in this context, okay. Of course, on the new specification, you are allowed to use calculators, so if it does ever appear on the exam, then in the current specification, you are able to use a calculator, but it's always important to know how to do the written method as well, okay. So feel free to always check using a calculator in this current specification. Okay, in the September 2017 teaching. Okay, question number 1A from the January 11 paper. Find the value of 16 to the minus a quarter. So the minus is the reciprocal, so it's 1 over 16 to the power of a quarter. Power of a quarter just means the fourth root of 16. So it's 1 over the fourth root of 16. Now the fourth root of 16 is equal to 2, because 2 times 2 times 2 times 2 gives us 16, guys. Okay, so the answer to that question is a half, or 0.5. Okay, so this is looking at fractional indices. Okay, again, in the current specification, you are welcome to use a calculator. Okay, but it's still important to know how to do the written methods. Okay, I don't mind you checking your answer with a calculator. That's not a problem, but make sure that we're happy with these written methods. Part B, simplify this indice or index. So I'm going to have 2 to the power of 4, which is going to be 16. Now, x to the minus a quarter all to the power of 4, well, I'll just multiply the powers together. So minus a quarter times 4 is minus 1, okay? So minus a quarter times 4 is equal to minus 4 quarters, which simplifies to 1. Okay, putting this x back at the front, so x lots of this. Okay, well, I'm going to have just 16, because x to the minus 1 times x to the 1, imagine it's an invisible 1 there, you would add the powers, okay, 1 plus minus 1 goes to x to the 0, x to the 0 is equal to 1, okay, so the answer you get is just the number 16. Question number 3, guys, looking at rationalizing thirds, is from the Jan 11 paper. Simplify this third, giving your answer in the form p plus q root 3, where p and q are rational numbers. So we're going to multiply top and bottom by its conjugate. What that means is I'm going to multiply top and bottom by the denominator, but changing the sign, okay, to a plus. Okay, and the reason for that, guys, it will become clear in a second, but essentially I end up having the difference of 2 squares on the denominator, so I no longer have a third on the bottom of my fraction. Root 3 times root 3 is root 9, which is going to be 3. Root 3 times 1 is going to be plus root 3. Then I've got minus 1 times root 3, which is going to be minus root 3. Okay, then I'm going to have minus 1 times positive 1 is going to be minus 1, okay, because a negative times a positive gives me a negative, okay. On the top, I'm going to have 5 lots of root 3, which is going to be 5 root 3. Then I'm going to have 5 times positive 1 is going to be 5, okay. Then I'm going to have minus 2 root 3 times 3. Well, root 3 times root 3 is going to be root 9. The root 9 is equal to 3 times that by 2 is going to equal 6, but I've got that minus sign, so it becomes a minus 6, and then it becomes minus 2 root 3, because minus 2 root 3 times positive 1 is going to be minus 2 root 3, guys. Okay, simplifying top and bottom, okay, so collecting like terms. On the bottom, I'm going to have a 2, okay, because they're going to cancel. 3 take away 1 is 2. 5 root 3 take away 2 root 3 is going to be 3 root 3. 5 take away 6 is minus 1. Okay, now I want it in this form. Okay, so I'm going to have minus a half, okay, plus 3 over 2, okay, root 3 on top. Okay, where p would equal to negative a half, okay, and q would equal to 3 over 2, okay. Remember that a rational number, okay, just means that the equivalence of a decimal is terminating. So obviously minus a half and 3 halves, okay, both are going to be like terminating decimals, okay. So rational numbers are either fractions, okay, or whole numbers, okay. So I've expressed it in that form, okay. So I've just switched it up here, okay, by saying I've got 3 root 3 over 2 minus a half, okay, and I've just switched that round to make it in the form that it asks me in the question, which is going to be p plus q root 3, okay. Right, guys, next question. Okay, question number 1. Okay, find the value of 25 to the power of a half. Well, power of a half just means the square root. So there's going to be the square root of 25, which is 5. Okay, because 5 times 5 is 25, guys. Okay. So again, make sure that you're happy and clued up on your square numbers. Okay, and even cube numbers as well. Okay, 25 to the power of minus 3 halves. Well, the minus does the reciprocal. Okay, so it's 1 over 25 to the power of 3 halves. Okay, so the denominator does the root, so I'm going to take the square root of 25, and then I'm going to raise my answer to the power of 3. The square root of 25, we know from part A is 5, so I get 1 over 5, and then I'm going to raise that to the power of 3. I'm going to raise it to the power of the numerator in my fraction. Okay, 5 cubed is 125. 5 times 5 times 5 is 125, guys. So the answer is 1 over 125. Okay. Right, guys, next question. So 2A from the January 2012 past paper. Okay, simplify root 32 plus root 18, giving your answer in the form A root 2. Again, it's simplifying surds. So root 32 is equal to root 16 times the square root of 2. Okay. Here, it's giving you a hint, okay, that it's in the form of something times root 2. So one of your roots has to have a root 2. So that can this time help you deduce to work out like the missing square number that goes into the other surd essentially. But remember, just to be clear, guys, and just to go over this, I'm finding the highest number, okay, square factor that goes into 32, and the answer is 16. The square root of 16 is 4. 4 times root 2 is 4 root 2, guys. Okay, for that one. The square root of 18 is the square root of 9 times the square root of 2. The square root of 9, we should know that's equal to 3. 3 lots of root 2 is going to be 3 root 2, guys. Okay. Combining these together, so now adding them, I have 4 root 2 plus 3 root 2. That's going to equal to 7 root 2. Okay. So 3 root 2 plus 4 root 2 is equal to 7 root 2, guys. Okay. So that's how I simplify surds, guys. It's finding the highest square number that goes into it. So 7 root 2. Okay. Part B, okay, simplify this surd, giving your answer in the form B root 2 plus C, where B and C are going to be integers. So integers means whole numbers, okay, or negatives. Okay, well, the numerator can be rewritten as 7 root 2, okay, over 3 plus root 2, okay. Now, I'm going to multiply top and bottom by its conjugate. I'm going to multiply by 3 minus root 2 over 3 minus root 2, guys. And the reason for that, guys, is that we get the difference of 2 squares on our denominator, okay, and it just gets rid of the surds on the bottom part of my fraction. So 7 root 2 times 3 is going to be 21 root 2. And then 7 root 2 times minus root 2, or root 2 times root 2 is going to be root 4. The square root of 4 gives you 2. Okay, 7 times minus 2 is equal to minus 14. On the denominator, I'm going to have 9 take away 2. Okay, so simplifying this, I'm going to have 21 root 2 minus 14 all over 7. Okay, which I can start simplifying now because 21 divides into 7 and so does 14. So 21 divided by 7 is going to be 3. So it's going to be 3 root 2. Take away 2 because 14 over 7 simplifies to 2. Okay, it wants it in the form b root 2 plus c. So b in this case is equal to 3 and c is equal to minus 2. Okay, for that question. Okay, so that's rationalizing the denominator. If it's in the form a plus or minus root b, you multiply by its conjugate. So you multiply either by a minus root b over a minus root b or a plus root b over a plus root b, depending on what sign you've got here. If it's a plus here, you times by a minus. If it's a minus there, you times by the plus. Okay, so they stay the same, but you change the sign in between the two numbers. Okay. Question number 2a, evaluate this. Okay, so 32 to the 3/5, giving your answer as an integer. So it's the 5th root of 32. So the 5th root of 32, guys, is equal to 2. And then I'm going to raise my answer to the power of 3. So 2 cubed is 2 times 2 times 2, which gives me 8. Okay, for that one. For part B, 25x to the 4 all over 4 to the power of minus a half. Well, the minus flips it, so I get 4 over 25x to the 4. And then I'm raising that to the power of a half. Okay. So I'm raising everything to the power of a half, which means that I'm going to raise the numerator to the power of a half, the denominator to the power of a half. Okay, so 4 to the power of a half is the square root of 4, which is going to be 2. Okay, 25 to the power of a half is going to be 5. And then x to the 4 to the power of a half goes to x squared. Okay, so your answer is 2 over 5x squared. Okay. I'm going to be very clear and careful. It's not the same as 2/5 x squared. It's 2 over 5x squared. Okay, so it's 2/5 times 1 over x squared. Okay, so it's 2/5 lots of 1 over x squared. Okay, for that question. Okay, so power of a half, guys, just means a square root. Okay, so I take the square root of 4, which is 2. And the square root of 25x to the 4, well, 25 to the power of a half is going to be 5. And then x to the 4 to the power of a half, well, I'll just multiply the powers together. 4 times a half is 2. Okay. Question number 3, guys, from the June 2012 paper. Show that 2 over root 12 minus root 8 can be written in the form a plus root b, where a and b are integers. So I can do this one of two ways. I can simplify the third first and then rationalize it, or rationalize it and then simplify after. Either way will give me the same, okay, result and answer, hopefully. So I'm going to multiply, okay, top and bottom by root 12 minus root 8. Okay. So this is going to be slightly more trickier, okay, and a bit more involved, okay, because remember that I can simplify root 12 and root 8, but we will come to that in a second, okay. So by multiplying by its conjugate, I'm going to get an integer on the denominator of my fraction. So I'm going to get 12 take away 8, which is going to be 4. Okay, so that's obviously nice and easy. Okay, on the top, I'm going to have 2 lots of root 12 plus 2 lots of root 8. Okay. For that one. Okay. So let's just start cancelling now to make it a bit easier. So I'm going to have root 12 plus root 8 all over 2. Okay. And now I can simplify the numerator by simplifying each third separately. So root 12 is root 4 times root 3. Okay, because 4 is the biggest square number factor that goes into 12. root 4 is going to be equal to 2, so it's going to be equal to 2 lots of root 3. And then root 8 is equal to root 4 times root 2. Okay, note that this time I don't have like a common surd, but that doesn't matter. I can still simplify the surd, okay? Root 4 is going to be equal to 2, so I'm going to have 2 lots of root 2. So then the numerator now becomes 2 root 3 plus 2 root 2 all over 2, guys. And then I can divide everything through by 2. So I'm going to have root 3 plus root 2. Okay, or root 2 plus root 3. It doesn't really matter which way around you have it. Okay, I'm going to leave it, just like this here. So in this case, A is equal to 3 and B is equal to 2, but it can also be vice versa. It can be that B is equal to 3 and A is equal to 2. Okay, either way would be sufficient, okay, and suffice the answer to that question. Okay, question number 1 on the January 2013 paper. Factorize completely x minus 4x cubed while taking out the highest common factor. I've got x to the 1 here and x cubed, so I can take out an x. Okay, so x, and then I'm going to have 1 minus 4x squared. Okay, and I can check my answer by expanding that bracket. X times 1 gives me just x, and x times minus 4x squared gives me minus 4x cubed. Now note here, it says factorize completely. This is actually the difference of 2 squares, so I can factorize this into a double bracket. So I'm going to have x, and then I'm going to have a double bracket here. Okay, it's sneaky, okay, so it's recognizing your knowledge of factorizing quadratics involving the difference of 2 squares. It's 1 plus 2x, and then 1 minus 2x. For that one, okay, and you can check your answer, okay. I do the square root of 1, which is going to be 1, and then the square root of 4x squared is going to equal to 2x, okay, because 2x times 2x gives me 4x squared, okay. A positive 2 times a negative gives me a negative there. Okay, question number 2, guys, on the January 2013 past paper. Express 8 to the 2x plus 3 in the form 2 to the y, okay, stating y in terms of x. Well, this is recognizing that 8 is 2 times 2 times 2, so 8 can be written as 2 to the power of 3. So I'm going to have 2 to the power of 3, okay, and then in brackets, I'm going to have 2x plus 3, okay, because that doesn't actually change my answer. It's just writing it in the base component of 2. Okay, now the rules of indices state that if I've got a power raised to another power, I just multiply these together. So I'm going to have 3 lots of 2x is going to be 6x, and 3 lots of 3 is going to equal to 9. So in this case, just to obviously answer the question, y is equal to 6x plus 9, okay, or 9 plus 6x, okay. So in this case, y, okay, is equal to this part, okay, or the whole of that part, okay. So y is equal to this, sorry, just to be very clear, 6x plus 9. Okay, so it's writing it in base powers of 2, guys. Question number 3, guys, on the January 2013 paper. 3i, express 5 minus root 8 times 1 plus root 2 in the form a plus root 2, where a and b are integers. So expanding brackets with surds, 5 times 1 is going to be 5. 5 times positive root 2 is going to equal to 5 root 2. Minus root 8 times 1 is going to be minus root 8, okay, and then minus root 8 times positive 2 is minus root 16, which just simplifies to 4, okay, because root 16 is equal to 4. 4 times 4 is 16. And it's a minus because I've got a negative times a positive, so the sign is going to be a negative. Okay, now root 8 here can be simplified. Root 8 is root 4 times root 2. Okay, so root 8 is root 4 times root 2. Well, the square root of 4 is going to be 2, so I'm going to have 2 lots of root 2. Okay, so now I can start collecting like terms together. Okay, so replace that there. Okay, so that's now going to become minus 2 lots of root 2. That should be a 2 there, guys, not a 1. I apologise. Should be a 2 there. Let's just run that out again. Okay, looks like a 1 that did. Apologise. Oops. Okay, so collecting like terms, 5 take away 4 is 1, and 5 root 2 take away 2 root 2 is going to be 3 root 2, guys. Okay, for that one. Okay, part II, express root 80 plus 30 over root 5 in the form c root 5 where c is an integer. So root 80 can be expressed as root 16 times root 5. Okay, hint here, so it's giving you the clue of root 5. So root 16 times root 5, well, the square root of 16 is equal to 4, so I'm going to have 4 lots of root 5. Okay, and 30 over root 5, well, I'm going to rationalise that by multiplying top and bottom by root 5, okay? Because by doing that, it removes the surd on the denominator of my fraction, okay? So root 5 times root 5 on the bottom becomes root 25, which just simplifies to 5, and then I'm going to have 30 lots of root 5 on the top, okay? And I can divide top and bottom by 5, and I'm going to get 6 root 5, okay, for that part. Adding my answers together, 4 root 5 plus 6 root 5 is going to be 10 root 5. Okay, for that one, guys. Okay, now we're looking at some more rationalizing thirds, okay, from the June 2013 paper. Okay, I'm not quite sure what the R means there, so I apologize about that, okay. I'm guessing it's probably from like a more recent specification. Yeah, I'm not too fully sure about that, so apologies there, guys. Okay, so express 15 over root 3 minus root 27 in the form k root 3, where k is an integer. Well, root 27 is root 9 times root 3. Okay, root 9 is going to equal to 3, so I'm going to have 3 lots of root 3, okay, if I simplify that. Okay, root 27 is root 9 times root 3, okay. So sorry if I jumped like a step there, guys, but hopefully you're happy with that. Okay, root 9 simplifies to 3. 15 over root 3, while rationalising the denominator, so multiplying top and bottom by root 3. So I'm going to get 15 lots of root 3 all over root 9. Root 9 simplifies to 3, so I'm going to have 15 lots of root 3 all over 3, which simplifies to 5 root 3. Okay, 3 root 3 plus 5 root 3 becomes 8 root 3, guys. That one. Okay, question number 5, part A from the June 2013 Edexcel Core 1 paper. Solve 2 to the y equals 8. Well, 2 cubed is equal to 8, so y is equal to 3. Okay, now if you weren't sure on how to solve this, I know I've not actually covered this yet, but you would use like the logarithm, so you would use like the rules of logs to solve that equation. So you would take logs of both sides, okay, bring the y down, and then you would have y is equal to log 8 divided by log 2. Okay, I know I've not actually covered that yet. Okay, but obviously the answer here is going to be a whole number, but if it wasn't a whole number, then we would use like logarithms, okay, to solve this equation, and I am going to cover that in a later video, okay. So I'm going to be covering logarithms and the rules of logs and the laws of logs in a certain video, okay, in an upcoming video. Okay, part B, okay, 2 to the x times 4 to the x plus 1 equals 2, is equal to 8. So writing everything as a power of 2, I'm going to have 2 to the x times 2 squared. So I'm going to have 2 to the 2x plus 2, okay, because I'm essentially writing 4 as 2 squared. I'm going to have times 4 squared, okay, sorry, times 2 squared, okay, raised to the x plus 1. And then I can write that is equal to 2 to the power of 3. Okay, because 8 is equal to 2 cubed. I can now use the rules of indices to add the powers. So I'm going to have 2 to the power of 3x plus 2. Okay, by collecting like terms. Okay, remember that we are adding if it's the same base. Okay, x plus 2x gives me 3x. So I get 2 to the 3x plus 2 is equal to 2 cubed. Comparing the powers of 2, I'm going to have 3x plus 2 is equal to 3. I've got a linear equation that I can just solve. Subtracting 2 on both sides and then dividing by 3, we get that x is equal to 1/3. Okay, so x is equal to 1/3, and you can check your answer by substituting that into the equation, and you will get that the left-hand side is equal to the right-hand side, guys. Okay, so I've written everything as a power of 2 here. Okay, 8 is written as 2 cubed, or 2 to the power of 3. Okay, 4 is written as 2 squared. Remember that I use the rules of indices here. A power raised to a power, I multiply these. So I'm going to have 2 lots of x plus 1. So if I expand that, I get 2x plus 2. Okay, which gives me this part here. Okay, and then I use the rules of indices to state that if I multiply with the same base, I just add the powers. So x plus 2x plus 2 goes to 3x plus 2 is equal to 2 cubed. And then I compared the powers of 2, okay, because everything is in base 2. Okay, and then I solved the equation by equating the powers together. Okay, for that. Okay, so hopefully that question makes sense, guys. Okay, question number 1 on the June 2013 paper. Okay, so we've got to rationalize this third, okay, giving the answer in the form a plus root b, where a and b are integers. So I'm going to multiply top and bottom by its conjugate, which is going to be root 5 plus 1 over root 5 plus 1. Okay, so on the denominator, I'm going to have 5 take away 1, which is going to be 4. So everything's going to be all over 4. I'm going to have 7 lots of root 5. Okay, plus 7 lots of 1 is going to be 7. Root 5 times root 5 is going to be equal to 5. And then root 5 times positive 1 is going to be plus 1 root 5. Okay, or root 5. Okay, collecting my like terms on the numerator part of my fraction. Okay, so collecting all the thirds together and all the numbers together. Okay, so 7 plus 5 goes to 12. 7 root 5 plus root 5 goes to 8 root 5. And that's all divided by 4. So dividing top and bottom, everything by 4. 12 divided by 4 goes to 3. And then 8 root 5 divided by 4 goes to 2 root 5. Okay, where in this case, a is equal to 3 and b is equal to 2. Okay, remember that integers means whole numbers, okay, positive whole numbers, okay, 0 and negative numbers as well. Okay, question number 3 on the June 2013 past paper 3 part A. Write down the value of 8 to the 5/3. So I take the cube root of 8 first. So I do the root of my denominator. Okay, the denominator tells me what the root is. That's going to be equal to 2, okay, because 2 times 2 times 2 is 8. And I'm going to raise that to the power of 5. 2 to the power of 5 is just 32, guys. 2 times 2 times 2 times 2 times 2 gives me 32. Okay. Part B, simplify this fully. Well, 2 to the power of 3 is going to be 8. X to the half all cubed, so I multiply the powers together. A half times 3 goes to 3 halves. Okay, and then I'm dividing all that by 4x squared. Okay, so it's simplifying indices. Okay, 8 divided by 4 is 2. And then x to the 3 halves minus 2. Okay, well, that's going to be 1.5. Take away 2 goes to minus 0.5. So it goes to minus a half. Okay, because I can write 2 as 4 halves. Okay, and then if I'm dividing, I would then subtract the powers. So I can write it as 4 halves. 3 halves take away 4 halves. Okay, is equal to minus a half. For that question. Okay, right guys, that's the end of today's video, okay, and that concludes the PDF document for the algebra and functions for the Edexcel Core 1, okay, exam style questions. We will now look at like a different section in the next video, okay, but hopefully this has made sense, guys. This is revising the rules of thirds, okay, expanding single and double brackets, okay, rationalizing thirds, okay, and many other components, okay, rules of indices, fractional powers, and all these guys, okay. So make sure that you revisit these topics or any part of this video if you weren't sure on any bits. Please put in the comment section on any questions that you weren't fully sure, okay, how to do, or if I didn't explain anything very clearly. Hopefully it makes sense. Okay, any questions, any queries, put it in the comment section. Thank you so much for watching. If you're new to the channel, make sure that you subscribe, okay, like this video, and also turn on post notification by clicking that bell icon so you are notified of when I upload for the AS Pure Maths, okay, and the GCSE videos as well. Okay, and the occasional Key Stage 3 and Key Stage 2 videos and Key Stage 1, as well as the occasional A-level further pure maths as well. Okay, but that's it for me today, guys. Thank you so much for watching. My name is Abdallah W, and I run this channel, Abdallah Maths Tutoring 2022 channel. Okay, and I'm also a private tutor, so if you want some extra support with your maths, then please get in touch. Okay, but that's it for me today, guys. Thanks for watching. I'll see you for the next one. Okay, bye for now.